Hello, this is Raph Alvarado and welcome to Exploratory Text Analytics. In this video, I'm just going to give you a quick overview of the story I asked you to read, The Library of Babel. So The Library of Babel is a story, it's a short story written by the Argentinian author Jorge Luis Borges, who was born in 1899, passed away in 1966. He was a librarian in the National Public Library of Argentina, professor of English at University of Buenos Aires. And he's really famous for these very short philosophical essays that are widely regarded by the digital media community as being very salient in representing some of the paradoxes and interesting aspects of knowledge and its relationship to text and logic, for lack of a better term. What I'm introducing you to today is a story called The Library of Babel that is basically an allegory about the nature of textuality. It's very pithy. It covers many points and goes off in lots of different directions. It begins, of course, if you read the story, with the premise that the universe is a library, which of course is a kind of conceit, a kind of inside joke about the nature of knowledge. We basically understand the universe through text, but also it's a real statement about thinking about the universe as a kind of text, which it kind of has to be in order for nature to be understood through text. But we're not really interested in that so much in this reading. I'm using it primarily as a means of setting up the question of information, or the concept of information, and how it relates to text analytics. It's an interesting connection, because the concept of information, as we're going to develop it, is something that helps us understand text, but it also is something that is inherently textual. And I hope to make that clear by looking at this parable that Borges has given us, and looking at the work of Claude Shannon, who invented information theory, how his work and his ideas help understand what's going on in this parable. So the Library of Babel is based on this premise that there is a library that consists of all possible books of a given structure. He posits this library as having a physical structure, as I just showed you, something like this, a bunch of hexagons, each of which has 20 bookshelves, and are all connected to each other through these walkways, which extends infinitely in all directions. Think about a library, this massive sort of beehive of a library. And on each shelf there are books, and each book is essentially the same structure, has the same document structure. Every book has 410 pages, and every page has 40 lines, and every line has 80 characters. And the alphabet that's used in the book consists of 25 characters. And I believe it's either 24 or 25. And a couple of those characters are the space and the period. So it doesn't have all the punctuation that we normally think of, but it has, a sufficient character set to write down a great deal of things. So what this basically boils down to is that every book, if you think of it, is essentially a very long string. It's a string of 80 times 40 times 410 characters, and so it's 1,000 or 1,310,000 characters in each book. So imagine a library where you have a bunch of books that are all identically structured, but each one is a unique permutation of those characters along that length of string. As a side note, note also that the books don't have an OCO character. They're not divided into chapters and so forth. If such things do exist in the book, they'll be signified by notation similar to what we saw in the Gutenberg text, where you see chapter 1, new line, signifying a chapter in Jane Austen's text. So what kind of content does the library contain? So if you have books that are of this particular structure, and you have every possible permutation of that structure, what kinds of things does the library contain? What kind of content does it contain? Well, it turns out that it contains everything. It contains every book ever written, as well as every book ever to be written. It contains every book in every language, transliterated, of course, into the orthography of the character set. It also contains every possible variation of every book. So imagine that it contains Jane Austen's Persuasion, a book, and you can imagine that as being so let's say it's less than 410 pages, that the rest of the book is blank, for example. So imagine a nice version of Persuasion being generated in this library. It would consist of the novel plus a bunch of blank pages. But it would also, the library would also contain every possible variation of that novel, a novel in which the entire word sequence is reversed, or a novel in which all the words that have the letter E are missing the letter E, or whatever you can imagine. It's also important to note that the library contains almost anything that can be represented digitally, because digital representation is essentially textual representation. So it also contains every image, every YouTube video, anything, every program that's ever been written. And the way you can get around thinking of the idea of, well, how does it contain, data files, if you will, that are larger than the book? Well, just think about a book along with however many other books are required to represent that data structure or that file. The library is going to have it because it contains every possible permutation of string. So it's a pretty darn big library, right? So we want to ask ourselves, how many books does the library actually have? You may want to pause here and calculate this yourself and come up with the value. I've given you enough information, which is the number of characters that the library, each book in the library has, and the length of the string, so you can figure out, based on those two values, how many books there are based on how many possible permutations there are. So I'll pause and then, okay, so here we are. It's basically this. You have, if you take the number of characters as your number and you raise it to the power of the length of the text, the number of positions, that will give you the number of possible permutations. That is to say, the number of books in the library. And you can see it's a pretty large number. It's something like 2 to the 1.8 millionth power. A very, very large number, which is effectively infinity. You can verify this in different ways. I went to Google and entered that equation. You can see it up there, 25 to that particular power. And Google, obviously it can't compute something that large, so it simply says it's infinite, gives infinity as an answer. So there are an infinite number of texts in that library. So given that, how likely is somebody using the library able to find something readable in the library? How likely are you to find not even Jane Austen's Persuasion, but how likely are you to find any text that you can read? And this applies for anybody, for any language. So if you're coming at this looking at it from a German, looking for German texts, or looking for English texts, or looking for Hindi texts, you're going to run into the same question. The same probabilities will apply. Consider this fact. Just one authentic volume. Now, I'm thinking about the example I gave you earlier of Jane Austen, together with all those variants containing only a handful of misprints. So Jane Austen's Persuasion plus Jane Austen's Persuasion, where the letter T is missing from the word the halfway through the book, or Jane Austen, where everywhere throughout the book the name Wentworth is misspelled. Think about all those possible variants of a particular text. The space that would be required just to house those books is larger than or would fill the known universe. Now, that's pretty big. Now we're talking about one book and its variations. So obviously this library is many, many universes large. Indeed, it is infinite. And all we've done is take a single string and permute it with a relatively small character set. We're not even using a character set that you would normally use if you were to write something in Microsoft Word, say, where you would be using potentially the Unicode alphabet or character set of 16 million characters, but more likely the ASCII character set of 128. We're using something much smaller. Here's a Twitter feed that's based on this story. So there are a lot of people who've taken an interest in this story and have sort of played with it and experimented with it. And here we see a Twitter feed called Library of Babel, where every tweet is presumably a passage from a book in the library. And here you get a sense of what kind of text you see here that this library is likely to have. So if you were to pick up a book and open up a page and start reading, you're going to run into things that look like this. And indeed, these are randomly generated, just as a reader might randomly pull a book out of the stacks. Here's another variation of what a Library of Babel text might look like that was generated by somebody else. And you can see the same thing, that it's pretty much gobbledygook to us. So the question we want to ask is, given this library, given the existence of this library and its high aspirations to represent all knowledge, and yet providing any reader with no knowledge, simply because it's impossible to find a text in there, how do we characterize this library in such a way as to understand why it doesn't, quote unquote, work? What's broken about it? How is it different than the Library of Congress, or the British Library, or the library at the University of Virginia, Alderman Library? How is it different to those things? How would we characterize that? Well, the problem with this library is the following. It basically contains all possible strings, not probable strings. All right? It contains possible strings, not probable strings. And this is a very important concept we need to understand, is that language, as produced by human beings through speech acts as described by Ricoeur, is not just a series of words that are generated randomly, but words that are generated stochastically, which is to say that it's a combination of randomness from the perspective of people listening, but also the product of a selection process due to what we would call latent variables. There's some mechanism that is actually selecting letters and words to produce the sentences that we say and to produce the books in our libraries. And this selection principle is governed by a probability distribution, or it can be modeled that way. And there I'm jumping ahead to the notion that we're going to get to later of a language model. But just realize that the difference between a library, a human library, and the Library of Babel is really one of a difference between possibility and probability. The Library of Babel is the entire sample space of textuality, but in reality, we work with a much reduced subspace of the entire sample space of text. And we're going to talk about what principle will help us understand this subselection and how we can characterize language in a way that isn't as problematic as the one that Borges describes, one that's generated purely on the basis of a mechanical, run through of all possible permutations of a character set within a given size. Another way to think about this is that the messages in the Library of Babel are not locutions, as we've talked about. They are not speech acts as we understand them. Instead, they're mechanically generated according to a principle that has nothing to do with the production of meaning per se. So this gets to this notion of how meaningfulness and probability are related to selection, and how selection takes place in a locutionary context. So I'm going to leave it there to set up what we're going to talk about next, which is Shannon's theory of information, which helps us understand these concepts further.